Alright, today's video is about graphing inequalities, and once you have that inequality graphed, how do you write the line of that inequality? So our objective is students will be able to write the inequality from a graph. So the read the directions says write the linear inequality, these two words should be familiar to us, in slope-intercept form for each graph below. So let's kind of dissect what these different words mean. Linear meaning a straight line. Inequality meaning we're going to have some sort of symbol that's an inequality, so whether it's a less than or a greater than, or a less than or equal to or greater than or equal to. And then slope-intercept form we should also be familiar with because we know that that is y equals mx plus b. So when we graph a linear inequality, or we write a graph from a linear inequality, all we're doing is replacing our equal sign with some sort of inequality symbol. So in order to do this, it's going to be very similar to writing the equation from a graph. We know that in order to write our equation in y equals mx plus b form, we need two things. We need m and we need b. So the first thing I'm going to find is b. Now this graph is a little bit tricky because it's going by twos, so it's 0, 2, 4, 6. But you can assume that halfway between, that's going to be 1. Halfway between here, that's going to be 3. Halfway between here, that's going to be 4. And the same goes for the y-axis. Halfway between is 1. Halfway between right here is 3, 4, 5. So it's important to look at the scale of your graph. Now if I look at the scale and I'm looking at where does this line cross this axis, I notice it crosses at a positive 3. So my b is a positive 3. Next I want to find my slope. We've talked in the past about finding perfect points. Now, I'm looking at this, and there's no perfect points that this line goes through where it crosses right at a T. But if I'm using my scale where I'm going up by 1, this point right here crosses right in the middle at 0, 3, so I can use this point right here. And this point right here crosses at 1, 4, so I can use this point right here. I'm going to go ahead and I'm going to draw my slope triangle. Remember that slope is rise over run. Now again, this one's a little bit more difficult because we don't have a scale that goes by ones, but we can still use this. So from 0 to 1, how much do you run? You run 1. From, this is the 3 to 4, how much do you rise? 1. So our slope is going to be erase this so it's a little bit bigger. Our slope is going to be the rise over the run. Our rise is 1. Our run is 1. So to simplify that, that becomes m is 1. Now just to check, is your line negative or positive? From left to right, my line is going up, so my slope is a positive 1. Alright, now we have m, we have b. We're going to start to put together our equation. So we're going to write y, leave this blank for right now because we'll put an inequality symbol. My slope is 1, so 1x plus 3. Now, we need to figure out what sort of inequality symbol will go here. Will it be a less than? Will it be a greater than? And the first thing that we need to do is look at the line and see whether it's dotted or dashed. Remember that a less than or a greater than, we use a dashed line. If it's a less than or equal to or a greater than or equal to, we use a solid line. On our graph, this is a dotted line, so we know that we're going to use either a less than or a greater than. So are the numbers on the line a solution? It does not include the line. It's a dashed line, so the answer to that is no, and we know we're going to use a less than or greater than symbol. Then we need to figure out which way is it going to be. Is it going to be less than or greater than? In general, we've talked about if you shade above the line, it's greater than. If you shade below the line, it's less than. So I'm going to assume that it's greater than, but we should pick a point just to be sure. And I'm going to pick a point, put it into this equation, and see if it works. So I'm going to pick this point right here, which is -4, 4. So I'm going to pick the point negative 4, 4. If this is correct, if we drew the right inequality, this point should be true. So let's do our check right here and see if it works. Is, my y value is 4, is 4 greater than 1 times negative 4 plus 3? So let's see. Is 4 greater than 1 times negative 4 is negative 4? Is 4 greater than negative 4 plus 3 is negative 1? Is 4 greater than negative 1? Yes. My check worked, so I drew my inequality symbol correctly. So my equation is y is greater than 1x plus 3. Let's do one more example. So example 2. Again, we need to draw the equation of the inequality of this graph. So we know the equation is going to be in slope-intercept form, y equals mx plus b. The first thing we should find is our m and our b. So I'm looking at this, and I notice that here is my y-intercept. This graph, again, is going by 2s. So remember, this is 1, this is 2, this is 3, 4, 5. So here, halfway tuned, will be 1, 2, 3, 4. This is 5. So my y-intercept is 5. Now to find b, I'm looking for perfect points. And I don't see any perfect points here, but I do see that there's these 2 perfect points that go through a whole number. It's just not on the scale. So I'm going to draw my slope triangle. Now it's a little bit harder to count because you can't just count 1, 2, and a half. But we can say, okay, from 0 we went 1, 2, 3, 4, 5 over. And how many did we go down from 5? 1, 2, 3, 4, 5. So I know slope is going to be rise over run. I had a rise of 5. I had a run of 5. Now before I write my final answer, I'm going to go back here. I'm going to look, is my line negative or positive? Well, from left to right, it's going down. So it's a negative, and 5 over 5 is 1. My slope is negative 1. So I know my equation needs to look like this, and I'm going to go ahead and write it out without putting an equal sign or an inequality. Y is some sort of inequality sign. My slope was negative 1, so negative 1x plus 5. Now let's determine what inequality sign we need to use. Remember, if it's a less than or a greater than, we're going to use a dashed line. If it's a less than or equal to or a greater than or equal to, we're going to use a solid line. This is a solid line, so that I know I'm going to use one of the equal to's. So I'm going to go ahead and put that here because I know it's going to be a solid line. Are the numbers on this line a solution? Yes. Remember we talked about in the previous objective, it includes these numbers. I notice that I'm graphing above, so I'm thinking it needs to be a greater than, but I'm going to pick a point just to check. Erase this so I have a little bit more room. So I'm going to pick a point right here just to check, and this point is 4, 4. So let's test the point 4, 4. Is 4 greater than or equal to negative 1 times 4 plus 5? Negative 1 times 4 is negative 4. Bring down my 4. Is 4 greater than or equal to negative 4 plus 5 gives me a positive 1. Is 4 greater than or equal to 1? Yes. I used the right inequality symbol. Just so that it's clear how we would tell if it's fake is let's say we accidentally put a less than symbol. Let's say we put something over here. And let's say that our inequality we thought would be, let's say we thought the inequality was y is less than or equal to negative 1x plus 5. If we were to pick that same point, 4, 4, and put it in, we would have had 4 is less than or equal to negative 1 times 4 plus 5. Well, we would have, again, negative 1 times 4 is 4, and negative 4 plus 5 still gives us 1. But this inequality says, is 4 less than or equal to 1? That's false. This doesn't work. That means we drew our inequality sign wrong, and we would have figured it out. So that's why this is correct. Alright, go ahead and pause the video. When you're ready, press play and you can see the different equations and try these two practices. Alright, here are the solutions to the first two problems. Notice on this one we had a slope of negative 2/3. Our b was 0, so we didn't include that because we don't need to put plus 0 at the end. But you do have a solid line, so it's going to include the equal to, and we should have shaded it was shaded below, so it's a less than. This one, our y-intercept was 4. Our slope was positive 4/5. It was a dashed line, so we know it doesn't need to be the equal to, and it shaded above, so it needs to be a greater than. Alright, two more practice problems. Go ahead and try these two. Pause the video, and then see the answers. Alright, here are the answers for the next two problems. This one had a slope of positive 3 and a y-intercept of 1. It was a less than because we shaded below. Also, it did not include the equal to, so we put a dashed line. Now this is a undefined slope, and it doesn't have a y-intercept. It actually only has an x-intercept. So when it's an x-intercept, we write x is less than 3. When it's an x-intercept, it will always be x equals and then where it crosses. So since we shaded below or to the left, we put a less than 3. Just so that you could see, if you had a line like this that went straight across the axis, went across the y, what's the slope of this line right here? The slope would be 0. What's the y-intercept? 3. So we would write that equation as y equals 3. Or if it was an inequality, we would write y less than or greater than or whatever. So just remember the difference between the y equals and the x equals. Alright, that's all your practice. You can go ahead and stop the video, write down any questions that you have.